So I've unboxed my Folger Tech FT-6 printer, and I'm ready to start trying to assemble the kit. But as you can see, we are currently still with an assembly guide version 0.05 alpha. And of course, if you dig into the guide, first thing you have is this alpha warning. This is an alpha version of the assembly guide. It has only been released as a preview of the completed guide that apparently doesn't exist. This guide is not meant to be used to assemble the kit. Do not follow anything within this guide as it may be wrong. So in other words, I'm just going to have to wing it, I guess. So why they're shipping something without putting out the completed guide is beyond me, but that's where we are. And so, jumping forward, we have our parts list for all the machine parts. We will see how close this is to what they're actually delivering now. Hopefully that's relatively correct. And we have the assembly information for how the rails go together with simple T-nuts. So these are typical extrusions. Very simple build design. And we have step one. So let's see if we can identify these parts and get started putting this together. So for starters, we dig into the bag of parts. Their recommendation is to go ahead and sort these all out into separate containers to make life a little easier. We will see if I decide to do that or not. Right, so it's about an hour later, and I've now sorted all of the goodies from this hardware bag into their appropriate categories. Luckily, I had these bins. I had to make up some dividers, which was part of the time, but sorting it wasn't a lot of fun. It ended up being easier than I expected. The ones that I really expected to have trouble with were the 8 and 10 millimeter M3s, but they actually sorted pretty easily. They were easy to distinguish. So, starting, you had separate bags for each size. So you had a set of M5, supposed to be 141. I'm not going to bother counting them. They pretty much have put extras for everything, it looks like. So M5 by 10s and the 143 M5 T-nuts. There's supposed to be 2 hex bolts. You'll see they gave me 3. There's supposed to be 6 nylocks. There's more than that in there. I think 8. Then there are these that are supposed to be M5 by 25s. For some reason, there's also a single M5 by 30, but that doesn't appear to be on the list. So I'm not exactly sure what that is. That may be part of the extras that I got, but we'll see. Then you get to the M4s. You got some M4 by 12s, 16s, 20s, set screws that really want to try to get away from you, and then the nylocks as well. Then we get down into the big bag, which is the M3s. So even though the M5s, yeah, it was a big bag, there's not that many screws in it. This one has all sorts of different sizes. 8s, 10s, 16s, then 3 different types of nuts, and then a small variety of other things, including some spacers. Then you've got the final bag, which has all of the elbows and some springs and nuts, obviously for leveling the bed, I would expect. And then various set screws that I didn't sort out because I pretty much ran out of room and didn't figure that was enough trouble to bother with. Well, one more bag I had to get into before I could start the first step of the assembly was to get this SHF8, which are these mounting parts here. So that was in all the mounting, which includes those parts, the 2 roller bearings there, 4 of what I assume are linear bearings, 4 rubber feet, and 2 lead screw nuts. And so I've got one more bin here. I'll put all those aside in, but I'm going to need 4 of those for this first step, so I'll keep 4 of them out and we'll proceed. So with my bolts and nuts all sorted out and all the other mounting components, I'm ready to start for the first step in the assembly, which is base plate. And so digging through the assembly for this BFP 05 and 07 and running the vacuum to clean them up a little bit, you end up with these two parts. The next step is to actually peel off the protective coating so that you get to the actual bare aluminum. And I don't know if I'll be able to do this on camera. Yeah, looks like it wants to come up. And so it's got actually a white painted aluminum surface. Very nice. So, I peel this plastic off, which there was at least one point I saw that did not survive, although it doesn't look like it actually caused damage. We'll see if there are any other bad spots. But basically, you have to peel this off, and then of course the other question is how badly burred are the edges, and you may need to do some cleanup in places. But we'll get these pulled off and take the next step toward assembly. Alright, so we have the plastic off completely, and now these two are set to go. Unfortunately, the one thing that we see is that we've got a little bit of a tooling problem here. For whatever reason, it looks like they actually hit it with the tooling in the machining, so it's not something that got scraped afterwards. Unfortunately, this particular part is not symmetrical, and so there's really no chance of flipping it over if that happens to be facing somewhere we don't like. That one you could flip and use either side. So here we actually see one of the first discrepancies with the drawings in the assembly instructions. If you notice the panel BPF or BFP5 on the left hand side, the whole pattern doesn't quite match. Mainly these holes here, here, and here. They're similar, but you'll notice they're showing that hole out here instead of in the center where it is. But otherwise they match, and going through the parts list, that's the only part that matches that even remotely. So actually I guess that's BPF 7. But anyway, so another comment on the documentation. These are the actual parts. So an M4x20, the M4 Nylock, and the SHF8. Typically in assembly manuals, one of the nice things to do would be to actually put an actual size drawing so that when you printed this thing out, you'd be able to just use that to determine if you had the right screw or not. Thus, having your handy-dandy calipers or something else around to be able to look at that will be quite helpful, because they did not do that. The other thing that you typically will see in an assembly guide is a entry at the start of the document to tell you what you need in the way of tools. In this case, most all of the connectors are using a Allen screw hex, but of course these are all metric, so you have to have a metric Allen set. So one other comment I wanted to make on this is looking at the machining itself. I'm pretty pleased there aren't any real sharp burrs. There's minor stuff you can feel as far as the aluminum. Most of the debris you see is actually, and there's a little bit of aluminum in it as well, it's mostly the plastic, which of course makes sense. You're running a tool, it's heating up, it's tending to melt that plastic as much as it is machining it away. And so, that is kind of the challenge of these composite materials. Now, the really nice thing about this is these things are incredibly light for something that essentially has the same rigidity as a panel that would probably weigh about 10 times as much if it were solid aluminum. These are very nice structural design. Alright, so after a couple of false starts, we have the first two pieces done, basically the first step of the Z assembly here. Part of the problem, all of my great metric tools, sockets and whatnot, as well as Allen wrenches, are out on my land where I work on my tractor and telescope and all the other stuff out there. So I don't have those handy here right now. What I do have is this really nice set of boxer tools. I was counting on this stuff that I have, a screwdriver set that has a bunch of hex bits, but unfortunately they're all English, not metric. So much for that. But this boxer set should get me through. We'll see when I run out. And then, of course, just a trusty crescent wrench to be able to adjust that. I am operating under a couple of assumptions that aren't mentioned one way or the other in here, but since this is going to clamp rods going across, I'm leaving these loose for the moment. I expect I'll come back later and tighten them up the rest of the way. The other thing, there's a decision to be made about which way to face the clamp screw here. But since there's going to be another rod here in the middle, I decided I'm going to face those outward, assuming that they'll be easier to get to, unless, of course, I have to adjust those after putting a cross plate here, in which case I might want to really put them on the inside. So we'll see how that works out. Alright, now, so we're done with the second step, which is to add these two bearings. You'll notice that the screws all still go the same direction. So while the bearings are on the other side of the panel, these will actually be holding the drive shaft later. The screws go in the same way, so the nuts are all on the bottom. This is essentially the top side, looking forward a few pages. So unfortunately, that means this scratch is going to be nice and visible. Unless there's something that actually comes up and butts up against that. The extrusion may take care of that. The good news is this is actually the back side. So this is the right side, this is the left. So these are flipped around from where they'll be when it's assembled. The next step then is to actually work on the drive component. And so we get to pull out some stepper motors and some jumpers and everything else. So this should be fun. So I thought this was where this video was going to end today. As I pulled out the next two parts, the BFP 8 and 9, which are the top components to mirror those bottom ones. What I saw was that for several of these holes, the tooling did not actually penetrate the bottom layer, which had me a bit worried that something had broken or just worn to the point that it wasn't fully penetrating the aluminum. Instead, what it appears, I've already cleaned those out, what it looks like is that this plastic is just building up around the tooling and pushing the coating down. And so there's just basically a big wad of not quite melted and gobbed plastic, but it's a mess pulling it out, and it's just shavings of plastic and aluminum. So luckily we can continue. A couple of other points I wanted to make. One comment on just the way things are mounting. You notice this is just a slot with bare aluminum. And if I'm putting this screw into that slot, it is just a little bit, the head's just a little larger than the slot, and of course I'm twisting against the slot when I tighten it down. Same thing for the nut, and actually worse for the nut, because the nut has the square faces to it that will rub against that. While it would be an added cost, what this really needs is, and frankly it would be a pain to install them too, this really should be using washers against this, so that you have the washer there that's the smooth surface that's wider than the slot, will hold it regardless of whether it's the nut or the screw head, and actually provide that additional backing. So that's a shortcut that I really think they ought to fix in the future. It would also require slightly longer hardware to make sure that they took up the space for the washer. But it would make for a better product in the long run. So after quite a bit of cleaning, we now have these two parts ready to go. There was actually, most of these holes were all completely clogged. And typically the little aluminum part was sitting there on top of all the plastic. Kind of like that hole still has a little bit in it. Now we get into some of the other hardware. We've got the 4 stepper motors that will be used. You'll see that they're all the same size, basically 5 kilogram per centimeter torque for all the axes. So we are going to need 2 of these, and pretty typical steppers. Decent weight to them. And then we need the 2 drive pulleys that are going to go on that, as well as the other 2 components to hold the other ends of the rails. The rest of this we'll put back in the bag and leave it alone. This was the belt and pulley bag. And so as you can see, we've got this belt loop, the 6 meters of belt that will be non-continuous, and then 2 different size drive gears, one that actually ties 2 different belts together, and then idler pulleys that will go on in the next step. Now, we've come to a problem. I was just mentioning the need for washers. This says to use M3 washers, but there are none in the kit. And frankly, there is no guidance here as to where those washers would actually go if you had them. Presumably, those were for the motor mounts, but that's hard to say for sure. Since you have 4 10 millimeter and 4 washers, the 20 millimeters and the nylock are what are used to put the SHF8. So that implies that the washer should be to help hold the motor, basically to address the same issue that I already mentioned, unless, of course, there's supposed to be spacers to space the motor off. Now, there are nylon spacers, but those aren't mentioned here. I'm going to dig through the rest of the instructions to make sure where those get used. But obviously, they're not going to work on a 10 millimeter screw anyway, so that wouldn't make any sense. Alright, so we have the 2 pulleys attached to the motors, and as you can see, if I can get this to focus well, and there you go. You can see the flat just barely there on the shaft underneath, and you want to make sure that you screw one of the 2 screws into that flat, and then of course the other one just goes into whichever side of the shaft you decide to put it on. That way you just ensure that you are not going to slip as long as you've got those tight. Now, I'm not putting any Loctite or anything else in here, especially since you never know what I'll have to adjust, but that might be something worth considering. One thing I did not mention, so the M4 screws that we've used so far are using a 2.5 millimeter drive. The set screws here use a 2 millimeter drive, so that's what I've got in here now. I'll try to remember to mention what I use on the rest later. The other thing, my big fat fingers, one of my big problems, frankly, has been being able to reach in here and grab a screw or a nut. And so my handy dandy jeweler's tweezers, I've had these for about 30 years or so, and I use them constantly, are just beautiful to just reach in there and grab what I need. So definitely something to consider depending on what you're using to hold all your screws. So we'll do a little more assembly here and then come back and show you where we're at. Alright, so now we have the 2 Z-axis motors installed, as well as the rail mount motors, or rail mounts I should say. So essentially looks the same. All of the screws are coming up from the bottom, nuts on the top, and again, since there's no particular guidance, I chose to face those out, and again left them just loose enough that I can move them around a little bit as we put the rods in and then align and tension everything. I did go ahead and cinch the motors down. I don't want those sliding around, but you'll notice that they are actually in a slot, and presumably this will be used to tension the belt once everything is installed. The one important point here that it's kind of unfortunate the washers aren't there is that because that slot is so narrow and the screw head is so small, that without the washer, there's a good chance that this thing, you could eat through the aluminum and have a real problem. So that's something that I'll definitely be contacting Folger Tech and finding out what they really intend to do. One other point on this, we'll see if we can get focused on it. So the directions say to basically make this flush when you install it. And so what that's doing is that's making it so that the belt drives almost at the surface of the plate. So again, it's just trying to make that belt so that it's very close to the top of the plate. And one more point while I'm here, these M3 screws that are used to mount the motor use the same 2mm bit that you used for the set screws within the pulley itself. So far, just those two and the 2.5. Alright, so here we're now working on the center plate of the base, and we've identified where that unlabeled M5 30mm goes that was not in the parts list. So we mounted the stepper motor. You've got 4 screws holding it right at the corners, so it doesn't have anywhere to go. There's no adjustment, so you might as well cinch it down. One thing to note, as you start cinching on this material, it is actually possible to feel it compress a little bit because, after all, it's not solid aluminum. It's got a layer of plastic in between. Again, another reason why this really should have washers there to get a little more surface area, get a better bite for the screws. Now, these are 2 idlers. They are going to be used at the very last steps to tension 2 different belts that drive 2 different things. So I've left them loose so that they can slide more or less in their slots. Interestingly, I don't know if they had a tooling problem or a programming problem on the machining, but the ends of these slots are not actually round. They kind of have an oblong oval shape to them. Now, the problem I see, it's like, okay, the 30mm versus the 25mm is to raise that second idler up a little bit. The problem is it does not raise it enough to match. This is what's going to go on here in the long run. You're going to have one belt driving the lower pulley, the other one driving the upper one. Now they're running off to the edge of the assembly, so there's a certain amount of change in elevation that will be supported, and I'm presuming that the pulleys are actually mounted both near the surface in terms of what this is driving. But at the same time, that idler is quite a bit shorter than it needs to be for this particular pulley. Now, the other thing, so the way they have this designed is you have one nylock screw, or nylock nut, which that stands for nylon locking nut. So it's basically got the little plastic nylon insert in it so that you bind the threads when you screw it on. So you have one on bottom, one on top, and you leave that loose enough so that the pulley can spin. The pulley actually does have a bearing, so I was a little concerned if it was just a bushing against threaded screws, but it does actually have a small bearing in there. And essentially here you've put 2 of those nylocks underneath to get the spacing. But again, it's not quite enough. Now, the challenge here is that when it comes time to tighten this thing down and do the final adjustment, you've got to be able to slip a wrench underneath that to grab that nylock screw. It is not moving without having a wrench on it. And of course, a standard size wrench, such as my crescent wrench that I'm using right now, will not work. I believe I've got some thin metric wrenches that I'll be able to use, but and potentially you could get in there with some needle nose pliers. But this is an example of where a tool set included with the kit that actually has dedicated, just the little punched sheet metal wrenches that fit these parts actually is a nice add-on. I probably have tons of those from other things. I don't know if I would have this size around, but those are cheap little additions to a kit like this that make a big difference in terms of the assembly. And so taking a quick peek at the other side, you can see the motor there, and again, just the two socket head screws. These are now the M5 screws, which means we're up to a 3mm drive to drive those. And with that, we now have all three panels that make up the bottom, as well as the two components on the top. So our next step is actually going to be to start putting together a frame and then put these panels on it. That's actually some good news, because the one thing, they talk about having a nice surface area to work on, but you also have to have quite a bit of storage area to be putting all your partially finished parts. So if we come over here and you see where I'm piling up all the parts in the corner here, trying to avoid putting pressure on things I don't want to put pressure on and scratching anything. So with that, we will start working on a frame and go from there. So at this point, we've got the various beams. These are the parts I think that were labeled as small beam, but I believe they're the horizontal beams, or the short horizontal. These are the long horizontal beams. They don't actually have part numbers listed on the assembly diagram. And there's actually two different types of small beams. There's a 2020 and a 2040. So the 2020 is going to be 20mm by 20mm. The 2040 is basically twice that. So it's two pieces in one part. So you can see here how this is actually one full beam. And looking closely at the drawing, it appears that the 2040 is what's being used on the sides at the base. And each piece, they're all taped together, but each one is actually wrapped in its own shrink wrap, and that presumably comes from the factory. That way, again, it's protection just like on everything else. Then they machine the ends, and what you can see happens is that this is now full of filings coming off of just cutting the ends. So we've got to clean that out in order to get this ready to assemble. Okay, so the good news is that most of the aluminum chips that are in there are actually stuck to this protective tape that is on the material. The problem is that when you go and start pulling this off, you're stretching the tape and it tends to fly everywhere. Again, my best method for doing this has been my trusty tweezers and just pull it. But as you pull it, you'll see how it overlaps on the edges sometimes, and there are gaps in other places. So this is not a continuous coverage with this material. The side effect of that is that the tape that was used to bundle it together, as well as the labels, leave residue on here that now I get to scrub off. So you can see the tape residue here, nice and sticky, as well as the label residue. So a little more work before I can actually put these parts together. Alright, so after some fingernail scraping and a lot of vigorous rubbing with a 91% isopropyl alcohol soaked shop towel, I managed to get most of the sticky stuff off of these so that they're relatively clean. Of course, I have to do that on all the remaining rails. If they just pack them in, wrap them first with the packing paper that they're using before they tape them with the labels and the packing tape, that would prevent this problem, because the actual tape that is designed to be peeled off of this does not leave a residue. It's only the places where that was not protecting anything that the tape that they applied, as well as the shipping or the part number labeling, caused the problem. One other thing to notice on the small beam, the side beams, you'll see that the two 2040 beams are 540 millimeters. They're actually longer than the 5 shorter ones that will be used on the upper structure. So a couple of notes on these L brackets used to hold the side rails to the long rails. If you look, you'll notice, I can get this in front of the camera, you'll notice that there's a notch. And since the design is to have the front face of this rail actually show up even with the rail that we're going to add to the side of it, we need that to go in so that notch can actually slide up and down, and that will let us adjust this rail flush with the face. So by being able to slide that back and forth, you'll be able to get this rail flush, and I'll show you that in a little bit. The other thing it says, it uses the colloquial name of Grub Screws. It's actually referring to, there was a whole set of different size set screws that came in the bag with this mounting hardware. I'm assuming, since it happens to fit, it's the silver set screws. Again, uses the 2 millimeter, I believe, bit. This one here, is that 2 or 1.5? Whatever the small one was. There are some other sizes in there, but the black ones appear to be larger. I'm not even sure they're the same thread, so we will be checking those later. But for now, I think it's the silver ones that I'm going to be using. Alright, so now I have set screws installed in all of my L brackets, and it's simply a matter of, again, looking at where the notch is, sliding that part in so that the notch lets me slide this all the way down the rail if I want, and then very carefully sliding that together, and basically we just adjust so that this is flush and tighten those set screws to pull everything tight. And now that I've got this, we get an idea of just how much of my desktop it's taking, and also the likelihood that at best I'm going to have to get a right angle adapter for my USB on my Robo 3D if that's where I decide to leave it. Alright, so there we have the bottom rails assembled. Now there is a little trick to the order in which you tighten these screws, and the issue is that as you push the screw in, it's pushing the clip into the rail, and so it's actually moving this way, which means if I tighten this one first, then the separation distance changes as this pulls in. The problem is I have the same problem going the other way, that as I tighten this one, if I've got this locked in already, then I'm moving where that rail is relative to the end. So the end result is that what you need to do is tighten them both just tight enough to kind of cinch it up but still let things slide. Then you adjust into place and you adjust each one until you clamp them solid. And once you get there, it's a relatively rigid, although I would not put any real pressure on it because that will snap pretty easily. But that's the way those go together. Now the one other comment I will make about this, these corners, is that a normal right angle L-shaped Allen wrench would be a lot better for tightening these down than this screwdriver approach that I'm having to deal with, just because it's easier to get in there and get some good torque on it. But now we get to start with one of the neatest things about these rail extrusion type systems, and we're using what's called a T-nut. And so as you can see, there's little grippers on it, and it's basically a nut that's designed to be able to slip down into the rail, but then when you start screwing it down, it turns and actually hooks the rail. So you can attach virtually anything to these extruded rails through using this T-nut concept. And so here I have one of the feet with the T-nut already installed, and so basically got the T-nut, and if I come and just twist that, you'll see it's now caught there, and I can just screw that down and it will clamp tight. It's got to go on the bottom, so we'll come back and redo that. But that's how those work, and you could essentially attach anything you want to a rail system like this using these little T-nuts with a screw into them. And so just like that, we now have a set of 4 rubber feet attached to the bottom of this rail assembly, all with those little T-nuts. And now we get to attempt to attach all of the top plates to this using the same mechanism. So we're going to lay this down and put the plates in and a whole bunch of those T-nuts to actually put those 3 plates that we've assembled back together. Alright, so here we are with our M5 screws and T-nuts all mounted in this panel. It's very important that you remember which way that T goes. You can see the beveled side actually goes facing outward away from the part, and the T part is going along the screw. If you put it on backwards, you're going to try twisting these in and they just won't lock in properly if it'll go in at all. You only need to put it on about a turn or so of the screw. You don't want to tighten it too much, or again you won't be able to catch it. So now the trick is going to be to lay this down into the slots and get all of those T's to fall into the slot. And I'm not going to try to do that while holding a camera. So after laying it in place and just shaking it back and forth a little bit, it fell right into place. And so now all I have to do is make sure I'm happy with the alignment. The nice thing is this will essentially square everything up. It also gives you an indication of just how close your rails are to what they expect. Now what I'm feeling is, while I'm flush on the front, on the back rail, it doesn't quite reach to the rail. So I can move this back and forth a little bit, but it's essentially showing that they've got, even though this is even in a little bit from being flush to the end right here, what we're seeing is that this plate is a little shorter than this. Don't think it's going to make much difference, and who knows whether all of those plates are exactly the same, but basically I'm feeling that the plate's a little short on the back and it's a little short on the front, but it will cinch in tight. And the good news is that once I cinch this down, essentially this thing will be very rigid. The structure is coming from this plate, not from the little corner holders. The corner holders are almost just a temporary part to put the frame together. Alright, doesn't look much difference, but there we are now, all cinched down and tight. Now this is a very rigid and solid structure because of this. The one thing I noticed as I went around tightening this, I started on the far end, and the same tolerance gap is here. So it looks like this is intentionally designed to just have a little bit of tolerance along all edges. And so by the time you cinch these down, the screws tend to pull it directly into the center of the rail. And so for the most part, it just looks like this is so that whatever goes on the front face won't interfere with this having been too long. So that's actually typical smart mechanical design. Alright, so now we have the other 2 panels installed and all of the screws cinched down all the way around. Unfortunately, as I feared, our little scratch is on top, and since there's nothing else going above that, that will actually always be exposed. The good news is, basically it's at the back of the bed, and we'll actually have the print bed riding above that, so no one's ever going to really see it. But nonetheless, it would have been nice to have a non-damaged panel. At this point though, even if they were to send me one, I don't think I'd want to take this thing all apart to try to fix that. So So the one thing I was pretty impressed with is simply the fit and finish. The fact that the tolerances here are very tight. It pulls together nice. You can feel that same gap essentially all the way around the edges, and overall it turned out quite nice, and of course it's relatively solid. My only concern with this being, this is essentially just an enlargement of their FT-5, which means that this rail doesn't have a whole lot of support here in the middle, right? So I mean, if I tap it, you can see it moving. I'm not sure. What I would have liked to have seen is that they went ahead and went with a double rail. Now, granted, you'll get structural support from the other members as we build this up, but I think for this wide width, it would have made a lot more sense for this base to have that double rail. I don't think an extra foot would necessarily help, simply because then you're also relying on the stability of whatever you're putting it on. And as you can see, if I have to cut across and put 1 foot on this desk, there could be a step between those that if I had an extra foot, now I'd have an unbalance just because of how I'm mounting it. So the 4 feet I think are good, but it really should have a 2x4 rail instead of the 2x2 rail. So these vertical rails must have come from a different vendor, or at a minimum a different lot number or something. They have a much thicker coating layer on the outside, so it was much easier to pull off than the fine stuff that I was pulling off before. I was trying to find an example of that. Here you can see a piece of that. It's very thin, very hard to get off. So these peeled right off, and the nice thing too was they had not used any packing tape. They just put the bubble wrap end caps on. Those pulled right off, and the only thing I've got is just a little bit of tape residue or label residue from where the labels caught a couple of these outside the tape protection. But much nicer. Would very much prefer to see this on all of them. Alright, so we've identified all the parts necessary for putting the vertical braces on. There's basically 4 of these parts. These are the BFP01. They're the ones with the hole all the way through them. And they're essentially symmetrical as far as the brace capability, but you'll notice that the design actually has a desired direction. So as you see here, and if we look at the actual drawing over here, you'll see that that is vertical. So we want that logo to be basically honeycomb-like. Now, the other 2 parts are the BFP 03 and 04. And so, as you can see, we have these 2 that are not machined all the way through. And these are going on the end where all of the power and control circuitry will be over here. So those do not go all the way through. And the interesting thing about this, again, this plastic is very interesting. If I run my finger across this, this is actually raised because this is rough where they machine the aluminum out, but the plastic essentially melted and grew, and of course you can keep scraping little bits of fur off of it forever. But it is actually kind of an interesting effect just because of the way the plastic expanded due to the heat of machining it. And then we finally have this piece that's actually going to go at the back end, and that will be the power inlet and ventilation. Now, in the process of opening this, I found my second damaged part. You can see here on the corner where it's got a little crinkle. Essentially, again, not shipping damage. This is something that happened at the factory. I suspect somebody pulling it off the machine or packing it up dropped it, and it's too expensive of a part to throw away, so they just shipped it. But you know, it's usable. It'll squeeze out. I'll put that face in wherever I use it, but it's just another example of a little bit of a manufacturing problem there. Now here we are with the first corner installed, and you can see now approximately how tall this is going to be. So it's going to be a beast. Good thing I never look out this window. And so this is actually the corner that was bunged up when it was dropped, and after clamping that down tight, it appears to have cinched in nicely. You'd never know it. So in this case, it's not a real problem. Well, have 3 more to go, but as you've probably heard, there's a pretty massive thunderstorm going on outside. The lights have flickered repeatedly, and it's getting late, so I think this is where I'm going to stop this evening. The one obvious note, while granted I'm here trying to videotape this, the estimate on how long this is going to take to put together, I think, is probably considerably shorter than it really takes. But we will call it an evening here and pick up in the morning. Alright, so now we have all the uprights installed to this point. I found that it's actually easier to insert one side and tighten it up and then add the other side. Now this particular corner will actually have this mount for the display board going in here, but that's not installed at this stage. I ended up using this as my square for squaring this up. You do actually need to use a square because the nuts and rail system won't actually pull perfectly square all the time. I ended up on this corner using one of the pieces for the top temporarily, simply to make sure that I got this all squared up at the base where it needed to go. And so the next step will actually have us going to add the top rails. And the one thing also for that temporary use, you actually have to then take this back off, and you have to be careful not to get the nuts stuck in the rail and take those out. But that's where we're at. So after a lot of scrubbing and vacuuming up of aluminum chips from everywhere, I have the remaining rails all cleaned up and ready to be used. Wanted to show again the difference. Turns out all the small rails ended up having the same thick coating like the verticals did, while the short rails have this thin stuff that just as you pull it off, this was about the straightest piece that I had left, because as you pull it off, it just ends up stretching. You can just see how easily it stretches versus if I take this one. I mean, I could barely even cut it with scissors. It was actually that thick. So now that we have those parts, we're ready to start the top portion. And we've got now these corner blocks. So instead of just the L bracket that puts this in, where this is only actually supported just from that little L from the side, and then this is what holds everything together. The top will, each one of these L's will hold the parts, and then it will sit down into the rail like so. If I can get that to go in. And so that's what you'll end up having there. And so the goal here with this will be that you can put the whole assembly together without trying to float the cross beams in the air, and then you can slip the whole top on. So that's what we're going to do next. So I now have all of my set screws installed in these T's, and I wanted to show a few things. First off, remember that just like the T-nuts, the set screws go in from the base of the T, essentially. So when you're going to insert these, you'll need to be able to actually access the head of the screw, so you've got to put them in the right way. Now, after filling 2 of these, I actually ran out of the silver ones that had come with it and started using the black oxide versions. And even then, I ran down to only having 3 of these little bitty short ones that I did not want to use because they don't have as much thread once they're tightened. And of course, the kit came with a whole set of these, and I'm actually wondering now if the intention wasn't to use these for everything, because the one difference between the silver units that you use, the silver ones that actually come with this kit, you'll notice how that face on that is completely flat. Whereas what the black anodized or black oxide do is, if you look closely, you'll see there's a little ridge there. So these are actually designed to really bite into the metal, and of course if you have something you want pretty, they're going to bugger it up pretty bad. But in terms of holding power, the black oxide actually have a lot better holding capability. So in some respects it would make a lot of sense to just replace them all with the black oxide. I've looked through and can't find anywhere so far that I need to use those for anything else, so I may come back and replace these before I'm done. Alright, so now we have the top rail assembled. I went ahead and swapped to using all black oxide screws. Not that I'm really concerned about getting good bite into aluminum. It's pretty easy to press into regardless, but I figured why not. I don't expect that I'll need these elsewhere, but if I do, I'll deal with it then. And so I just have to lift that up, put it on top, and tighten them down. The nice thing about these spacings is this is all extruded to be pretty well dimensioned. This piece should hold it out properly, so I don't have to do anything special here. We'll see if I have to loosen these up just to get it to fit on. So that pretty much just fell right into place, and then I went around and just tightened all the set screws in. It's pretty much a testament to getting the legs square that everything lined up without really having to push any of the posts any direction. A couple of them fell in directly, the others just minor adjustment to get them to align. So finishing up this step, we've got the 4 corner braces for the top. These are actually an extended size brace. You can see I've already got the screws in here for the horizontal bars that are going to go across here at a second level as part of the next step. Now, the interesting thing about that is that the horizontals here don't have any tie-in to the main rail. The only thing that's going to hold them are the 2 screws on each side. Again, they're just additional bracing and structural, and that should be enough. The one challenge is that since they didn't put a similar piece here, you're just going to use a small L bracket like at the bottom. This one will float up and down. You're going to have to actually manually hold that in place and try to get it at the same level and tighten everything down to keep it looking like this does. So that's a little bit disappointing that they just didn't go ahead and put this on the side as well. And there are the 2 long horizontal rails installed. Those went in pretty easily. Although the one thing I should have done was put the back rail on first, because then I was reaching through with that front rail in the way, which restricts access a little more. The other comment I was going to make is, I'm a pretty big guy and can reach to the back of this and manage to tighten those screws, but ideally, especially if you're working on this alone, if you had a central table that you could actually have out away from a wall and be able to work it from all sides, it would certainly be easier. The option of trying to pick this up and move it around is not necessarily a good idea. Okay, so what I've done is I've actually gone and mounted each of the corner gussets here and basically made them level with the bottom of the other gusset, so that when I go to put the cross beam on, it should automatically be at the same level, following the same hole pattern. And I wanted to demonstrate a little trick. You'll notice that all of these screws, the T's are at various angles, which makes it a little challenging to get these on. And I accidentally discovered a trick that works pretty well, and it was just kind of by accident, and of course very late in the game. But if you just come up and you hit these with the bar, what you see happen is now they're all lined up, and boom, that just slides right on in there. So that ends up being a very useful way to actually put this bar in, is, like I say, just come up, bump, and boom. And after tightening the screws, we are done with step 5 of the frame assembly. And you can see how nicely aligned those corners became, just pretty much all on their own by simply getting that gusset in the right place. And so we now have this monstrosity of a frame that we get to start hanging moving parts on now. So the next stage is going to be the X-axis assembly. And so that's where we start next. And that's going to be mounting these two assemblies in there. Okay, and with that, we now have our two X drive assemblies mounted in here. Since you're mounting from the bottom, want to reiterate with these T screws, it's very critical that you actually start with them relatively loose, so that you can be assured, and then you have to, especially since here you're working against gravity, you have to make sure you actually push the screw up into the slot before you start screwing it down and tightening it. Otherwise, you're going to potentially just tighten the nut down in the slot and it won't actually grab. And when you've got a whole row of screws across like this, there's really no way to tell that you've managed to get them all to grab. So it's critical that you are very careful about the appropriate process for using those to make sure they actually twist into place. And the other advantage of this is that essentially with this setup, you end up with these screws becoming these panels actually becoming your gussets for the horizontal direction to prevent corner-to-corner twisting. And so that's what we look like now. Get a little further back and get a full picture here. And there you are. Alright, well, it looks like I get to take a trip to Home Depot at lunchtime here and try to get some more M5 nylocks, because while the packing list comes with a total of 6, and we actually had 7 because we had the 5 that were necessary to be able to build this idler assembly. You see there's 3 on one, and there are 2 on the other. This idler assembly, of course, I need a total of 4 because I've got 2 different idlers. And So we need 9. We only got 7 because we did actually get the 2 on here. So either somebody read 6 upside down, or sorry, read 9 upside down and translated it to a 6 somewhere along the line, or otherwise they just didn't count properly, but we are definitely short some components. So this kind of stalls the process. I'll show you where these are going. So these are the idlers for the x-axis that basically go right in there, and we bolt those in, and those tie to our stepper motors. And this is where we were talking before about the fact that the stepper motors themselves, you can adjust their position some. Chances are, I think I'm going to look for some washers while I'm there, just because I really do think that those slots need some washers on them. And that will involve removing the steppers, but that's not that big of a deal. So I'm not quite ready to go to Home Depot yet, and since the other part of this step is to actually install the 2 long rails for the x-axis, I decided to go ahead and open up the bubble-wrapped set of rails. And I'm more than a little disturbed to see that these have been cinched together so tight with tie wraps that the 2 long rails are actually bent. You see, they're tied together at the edges. They've got the carriers in the middle, and they're cinched together again at the ends. You know, for something that's supposed to be a precision linear rail, to have that done to them, hopefully they'll straighten out once I pop the tie wraps, and then of course we'll now be relying solely on the aluminum rail to take the steel rail and pull it straight. So that's pretty disturbing. So I popped all the tie wraps, and luckily it looks like the rails pretty much pop back to being straight, so they've got a good enough spring steel to them that they didn't take a permanent set. I don't know, you know, if you left these this way for too long, though, you might actually have problems. But for the moment, they look like they'll do okay. The other thing I'll draw your attention to is you'll notice the tie wrap in the ends of every one of these. That's to actually keep that linear bearing carrier from actually sliding off the ends. Of course, to mount these to the rail, I'm going to have to remove those. So we're going to have to be very careful not to let that carrier slide off. So I'm going to leave them in there until the very last, because we've got to put a lot of screws into this shaft with the T's to be able to attach these to the rails. I also real quickly wanted to show you the back side of these bearings to show you why you don't want them to go off the end of the rail. If you look there, you will see the roller balls that are in both sides of that bearing. And if that were to go off the end of the rail, that would be a real nightmare to pick that up and put that back together. You pretty much have to disassemble it from the side and insert them in. So we do not want that to happen. I think what I'm going to do is put screws in starting from the edge, and basically we'll capture that. You're supposed to use every other hole. So once you've got a few screws in there, that should keep it from moving anywhere. Alright, so I've got all the T-nuts with these. This is the M3 hardware now as opposed to the M5. But all the T-nuts are in. You'll notice I've used tie wraps just as a safety precaution. You know, it turns out these are pretty stiff bearings here. So the reality is that this thing will sit there just fine. But if you make the mistake of actually grabbing this and lifting, it's going to slide right off. So, I was actually working with the smaller one here, which is going to be for the y-axis. And, at one point when I was moving around, I ended up grabbing this and it moved on me. Makes you a little nervous. In this case, it wasn't a big deal because I had my protection on the ends. Now, what you will find is it says to do screws every other hole, but there are even number of holes and even number of screws. and you basically have a choice. You could end up with not having a screw at the end, or you can end up with two missing screws in the middle. I choose the latter as being the better solution. That way the ends can't possibly move. The center is going to be pretty well held regardless. And the same is true, of course, on the long ones. So at this point, these are all ready to go, and I'm going to very carefully take the tie wraps off and stick them on the horizontal rails and get them centered. Alright, so we now have the two slider rails mounted here. The documentation says nothing about what those distances should be, so I'll feed that back. Best I can tell from the picture, basically what I did was I matched, or attempted to match visually, that gap on both sides, so as close as I could, and then I used the calipers and just transferred that over. So hopefully that'll work, because that's a lot of screws to loosen and tighten if I need to change the range. This thing should never get close to the edge of the rails, but who knows. So there we are. So the next is to actually put together the Y-axis components, which will be basically this, the last rail will end up mounting in here somehow. There's some adapter pieces to put on it. That will get the other rail, linear rail on that, and we will go from there. So back from Lowe's, and I now have some more M5 lock nuts. Needed more than just these two because there's some additional casters that will have to be added. What I'm not sure, all they have are zinc. I'm thinking the rest of this hardware is stainless, but I'm not positive. But hopefully that won't really matter under the conditions that we'll be operating on. So the next step are making these little assemblies for the Y-axis, basically to mount. You can see the 4-hole pattern, so those were going to match the rail system, and they've got a pretty neat design. They're simply just a square nut that gets captured there and cinches this down to a set of they're basically tab and hole type attachment. And so if you take and you leave that nut right at the tip of the screw, you have just enough room to be able to slide the tabs in and put it in. So you can put the screw and the nut on the first piece and slip the other and push it into the slots, but you have to have it right at the very edge, and then you screw it down till it's tight. And so those two are ready to go on the rail, and we'll move on to the next step of the assembly with those, which will basically be to add everything to the rail system. So put those two on the ends of the rails, and to put the linear slide on the other rail. Alright, so we have the Y-axis rail assembled now, and I started by putting the linear bearing on, just because that's easier. These are going to have to be able to be left adjusted, so that's another thing they don't mention in the documentation, but you need to leave at least one side of this loose, so that when you go to mount to these two plates, whatever the distance is there, that's the distance that you need to adjust to. This is just centered on the rail, so it's 5 centimeters from each side, and so that's what you're seeing here is a 5 centimeter gap. And in this case, I've left one side loose. The other thing to note here is you notice that there's a normal Allen drive screw, but then we have a hex head. And same thing here, the hex head on the outside. That's because when this thing's installed, you're going to need to tighten the bolt, but it's going to be right over top of this. So this is again where now I need a small, thin wrench to be able to tighten that hex head, simply because you can't get in there. You know, obviously you wouldn't be able to use the Allen wrench, but now you need to be able to slip a hex head wrench in there and tighten that once you get it in place. So that is another case for having one of those thin wrenches that I mentioned. So before I finish mounting this, I'll show you another problem with the documentation. The header here that shows the hardware to use is actually from the previous page. They failed to update that, and all it says in the text is using the M3 hardware. Well, so if you cross everything else off and said, well, let's use the 8mm, the problem is the 8mm aren't long enough. They just barely engage. You need to be using the 10mm, which will tighten up just before they bottom out on the hole. So that's the appropriate part, and you can see the significant difference there in terms of the amount of thread engagement that you've got. So that's just another fix that will have to go into the guide here. Alright, so now we have the 4 10mm screws in each side of this. Swing around here. And I've tightened the back screw on this, but I've actually left the front one loose because this is actually kind of a perfect opportunity to just see how that T is supposed to work. If I can hold this and do this at the same time. Let's go back to autofocus. And I'm starting. Alright, fine. So I just finally cheated this, and since I could see it, I twisted it into place using my tweezers, and that way I can now tighten it up. So, like I say, these can be a challenge if you don't get them started right to begin with, and the fact that I can't put pressure upward on this nut well enough makes it so that automatic rotation was tending to fail. So just something to be aware of. Alright, and with all the bolts tightened down now, this should slide very easily. As long as you grab it from both ends, it should slide quite easily. Or grab it from the center in this case. But it'll be driven from both ends. Alright, so now we are working on the putting the belts on the steppers, and the one thing you'll see is that I now have some washers around these so that I can actually slide the motors back and forth and actually have some meat there to catch when I tighten that down. These are actually number 6 washers. I didn't see any M3 washers, and frankly these give a little more surface area. They're a little loose on the screw themselves. And so over here, what you see is that I've actually installed the first continuous or non-continuous belt. They show just using a couple of tie wraps that you will find, or at least I found, in the electrical kit. Luckily I have a bunch of my own, but these are relatively small, and it turns out for this belt size I decided these were pretty good to use. So the idea is, once I've got that all tightened up, all I have to do is just push the motor over a little bit, pull tension on it, and screw it down, and that will provide the tension. But for right now, I'm going to leave it loose because I still have to do the other side. One thing, of course, is to be sure that you don't create a twist, because you could very easily make this into a Mobius loop or whatever, having rotated it around itself once or twice. And of course, as you fold it over, you're actually engaging these teeth so that it's not going to slip once you get those tie wraps tight. And of course, as always, it's a little better to cut a little long than too short, so be sure you double check. And now we have the rest of the material, and like I say, here's the little tie wraps we're using. So get the other side done, and then we can tension the 2 motors. Alright, and so there we see we've got the second side done as well. So now we basically have both of those. I attempted to leave about the same amount of slack in both so that the motor will tension to about the same position, somewhere in the halfway mark, so that if the belt stretches, I've got some room before I have to actually adjust the belt itself. So both of these actually have quite a bit of adjustment space before they're done. This one obviously is just a little shorter, but with that washer, that's not a problem. Now, couple of notes. First off, this inset is actually on step 3 when it's really supposed to be on step 4, telling you about how to do the tab. So the cable ties as shown is actually here. And so what I attempted to replicate is what they did, which is you notice how the block of the cable tie is on the side closest to the rail in each case. So that implies bringing the tongue through the backside so that the block actually wraps over. So if you see you bring this up behind the cable and you wrap that over, and then that will keep that there. And all that's really to do is to ensure that we don't have anything that might catch on this as it goes by. It shouldn't ever hang out that far, but just in case, you never know. Alright, so now we've cut all the cable ties off and tensioned the motors. You certainly want these about as tight as you can get them, so that, because any play in this belt is going to cause variation in the accuracy of your Y dimension data. So basically you should be able to just slide the carrier and it's spinning the motors. You're doing this with no load on the motor at the moment, and I may still want to tighten this one up. You can see how much play I've got there. This one's a little tighter, and we will probably make final adjustments as we get this worked in. The other thing I will attempt to show you, if it will focus, is cutting those tie wraps off. So you see how that block is actually on the rail side. The other comment here is I like to actually, when I'm clipping ties like this, I leave a little bit of the end on that. You see how that's sticking out there? Just because if it happens to slip a notch, you want to make sure there's still some meat there to hold it. And if you're lucky enough to have a tie wrap gun, you may not have to worry about this, but you want to make sure those are cinched up as tight as you can. And with that, we have our X-axis done, and we're ready to start, I believe, on the Y stage. Okay, so before I go to this next step, which is basically putting the Y-axis motor together, I wanted to share a few things. So first off, as you can see, we're building another idler assembly for the opposite end from the motor, and that requires 2 more of those M5 nylocks that I went and bought. So that's let me finish that off. The part, it lists the BFP20 here, which is this piece. Unlike most of the others, the one thing I noticed on this one, they had a lot of machine chatter. Something went really wrong during the machining of this part, so it is really rough. It almost looks like a 3D printed part, with the exception of the metal surface. You know, the issues with this, I don't think that Folger Tech is actually running the machine shop doing this. I think they're probably outsourcing that to a local machine shop, having them do that work. But, like I say, there's some quality control issues from whoever they're using that they really should look at. Okay, so that's going to be the top part that gives the structural support. The other thing it says is it mentions the Gantry Board. It's like, well, okay, that looks like that's a circuit board, although there was no detail. Where do I find it? Started digging through a number of different things, and because it wasn't in the main electronics package, it ends up, it's actually in the wire package. So And to a point, that makes sense, because all this is, there is no electronics on this. It is just a wiring harness, essentially. It's got 2 limit switches. It's got a jumper to the motor, and then it's actually using an Ethernet port. The funny thing is, even with the LEDs, I wonder, it would be interesting to see if they use those as status indicators of any sort. The one comment about this approach, I do see 2 resistors, so I bet those are for lighting up the LEDs. Ethernet ports are very low current connectors. And I know that by a painful experience on a $1 million project where we decided to use this to power a bunch of RF switches down the line, and basically the amount of current that we were drawing through the connectors, it was a beautiful solution. Let's daisy chain everything, made it look great, but it ended up welding the plugs into the connectors, and when we had to service things, you could actually not remove the plugs. So that was a hard lesson learned, never to do that again. I don't know how much current these draw or if that will be a problem. Presumably Folger Tech has been using this for other things. I don't know if other 3D printers have taken this approach. It's a neat solution from being an easy to obtain connector, but it's risky. So just want to see, we'll see what happens in the long run, but obviously we won't be able to tell you that in this video. Okay, so a few more pieces of information. So this calls out M3x16s. That's an M3x16, and it is now bottomed out in the hole. My only option is to go down to the M3x10s and hope that there are enough of them. There's a decent amount of thread engagement. It really feels like it needs probably an M3x12. I don't know, 14 probably would bottom out still. I'm not sure if that's 2 or 3 millimeters. So, another problem in the directions. You may also wonder, because the reality is you see these 2 tabs, this could potentially be flipped. The first thing you do is you follow the hole pattern, and you line up the hole pattern, but it would be possible to actually invert that, it looks like. The thing that I am relying on is actually on the next page, although there's this small indication right here that looks like it might be that connector. When you go to the next page and you look at the mounting, you can actually see the indicators on the PCB showing that all of the connectors would plug into the bottom side. So basically all the silk screen that you see on the PCB is actually drawn on that bottom side. So that's the other way to know that that's the correct direction. Alright, well, I'm going to get back to putting this together, but thought I'd add that. So, real quickly, here is the issue with using the 10 millimeter, which is why I say, okay, 16's too long, but 10's really too short. I'm only going to have about 1 millimeter worth of thread engagement as I screw this in. So about 2 or 3 turns of that screw, and we're bottomed out. Or not bottomed out, but we're tight. So I may actually go track down some longer screws. You know, it costs more in gas to go get it than the actual cost of the screws, but it's frustrating regardless. Alright, so now we have the assembly completed with the pulley on it. I was a little concerned from the picture that I was going to have to actually pull that back apart, because it shows that pulley as though it's below the face of the plate, but no, there's plenty of clearance to actually get to the set screw with this all mounted up properly. So that's just fine. Also have my last little idler pulley put together. It was interesting just putting this together. The nut from these new nuts that I bought was a lot harder to get on. The nylock is much tighter on that. So just an interesting tidbit. Nothing important there. Okay, so I've got this ready to mount, and before I do, I wanted to call attention to a few features that are additional problems. So I'd already pointed out the nylock that was missing, and it's not even labeled as a nylock here, although it is actually in the text. This is using the same M5 10mm T-nut combo that's been used to mount every one of these panels. But we now have the added thickness of a 063 PC board, which is 1.5 millimeters. So we are now 1.5 millimeters short, and with these nuts just barely engaged, they're already almost bottomed out. So I'm not 100% sure what's going to happen. But I also want to call attention to this feature here. And this is a design flaw, and I will attempt to show you here what the situation is. And what I would say is that this is the intended profile and the PCB has a problem. So, if we come up here, the intention is in that 5 millimeters of space that we left off the back side, those two nuts are supposed to go in there and capture that. This then becomes your y-axis limit switch. Your x-axis limit switch is over here. We'll have to see what that hits on. The problem is, if we look, see if we can get a good focus here. Look at what we're stopping on. We're actually hitting the PCB on the end of this rail. We aren't hitting that little board. If I push that up like that, then I make contact and that last screw gets in. If I go to that position, that screw on the back side where I've got my finger is actually hanging out of the end of the rail. So to make this work, assuming that those will even engage, sorry, let me go back to autofocus. To make this work, I am probably going to have to loosen up and move this entire rail forward about a centimeter to be able to make that work. I'm not sure what that will do to my build volume, but that's a pretty significant problem. Now, the other side of this, here's the idler. One thing I didn't mention earlier was it said, of course, to make sure that you had this particular piece that had the little bump out with the hole in it on the front. So your motor goes on the back, your idler's on the front, and again, had to get in there with needle nose pliers to grab that nylock, but this time luckily I could screw from the top, so it wasn't as painstaking as trying to get that clamped down. Alright, well there it is mounted. I ended up, I had to actually unscrew the screws till basically the nut was ready to fall off, but I was able to get them to twist into place. They're only holding on with probably one full turn of thread, maybe 1.5, so that's not very satisfying. And let's see if I can swing around here. I don't know if this will focus for me. Basically, that one nylock is just, or not, sorry, not like the T nut, is just barely inside that coverage. Like I say, I don't think that's what was intended originally. Somewhere between mechanical and PCB, they had a little bit of miscommunication, I suspect. Be interesting to see what they say when I report this. The other thing that's kind of interesting about just the assembly instructions, I'll go to a top-down here. You notice the motor connector is hanging out here. The connector it's going to plug into, or I expect it to plug into, is over here. I'm not 100% sure why you didn't just rotate this so that that was directly over it and have a shorter cable. We'll see when we see the cable assembly what that actually looks like. The final thing I did want to show is what happens to the limit switch as we go down. So here, limit actually engages on that back panel. So that's our negative limit switch that way. There's obviously nothing as a limit this way. From a mechanical stop, turns out my tie wrap's apparently my mechanical stop there. But that's okay. And this right now, this carrier does actually hit that limit switch. I don't know. You'll notice again the limit switch is a little taller than this, so I'm not sure. We'll see what we mount on top of that that may engage that. Alright, next step. Alright, so from the directions we're actually done with the y-axis for a little while, but I actually have a niggling suspicion that when we finish putting this together, it's going to be a similar mechanism to this, right? We still have some belt left, and so we're going to create this loop between the carrier and the adjustment is going to be to slide this motor down the rail that way. Well, there is no room that way to move it, so I would expect I am still going to have to come back and loosen this rail and bring it forward if that is the tensioning mechanism. Again, I'm not jumping to the end of the book in this case to look and see how the extruder mounts and is tensioned, but that's my suspicion. Alright, on to what we get to do next, and that is to start working on the bed and putting the Z-axis components in. So, I want to turn this sideways. Actually, it won't hurt to turn it sideways. That is your bed base. You'll notice again we have this partially machined out triangle indicating front and essentially top. The only problem again is it's just through the aluminum and it's left this rough layer of plastic sticking out. It'd be nice if they either went a little deeper just so that that was recessed, or slowed the tool down a little bit so that it wasn't melting and leaving that, it cleaned all of that garbage out. Again, not really a big physical thing, but it would just look cosmetically better and certainly not require... My fear is if I get in there and start trying to scrape all that out, I'm just going to scratch the paint up around it if the tool slips. So, for the moment, I'm just going to leave it as is. So, what we get to do is basically install our 4 linear bearings and the 2 threaded feed-through nuts that will go on the shafts to actually drive this up and down. Alright, so after a lot of screws that are using the 16 millimeter, they're actually a little bit longer than necessary, so you end up screwing for quite a while with each one of these. But we now have each of the linear bearings and the screw or nut attached to the main part of the bed. Now what we get to do is add the side rails to make it a little more rigid because it's pretty floppy in the long direction. Alright, and so now we have those 2 reinforcing rails installed. As you can see, it's the same square nut with a screw pulling it tight and then tabs to hold it in place. So there's the screw, there's the slot for the tab. So, in general, not a bad mechanism. The one thing to realize, and of course be careful just how much you tighten these, those slots aren't necessarily all that structural, because remember, you've got mostly plastic with just a little bit of aluminum on the surface that you're actually catching with that nut. So if you pull tight enough, it will pull out. So just be careful. Alright, so the next step is to put our heated bed on top of the mount, the base, and There's not a whole lot of detail other than just basically it's spring-loaded. You can see the silicone base and the wiring coming off. The one obvious thing missing from the instruction is, well, which side should the wires be on? Now, since all the electronics are going to be on this side, that's the logical side. So, starting from here, we have the front here, which means we want the wires to come up this side. So that's how we're going to lay this out. And so, come back in a little bit, and we will have this mounted. Alright, so using flathead screws and these little black springs, and then you can see the thumb screws on the bottom for adjusting the leveling. We now have the hot plate basically mounted to the base, and the next step is going to be to actually set it up here and thread all the rods through it, and then clamp those in place, which is going to be fun on the bottom since everything is underneath. I'm not exactly sure why they chose that. It may look okay, but frankly I would have just left it on top. I don't think it's a clearance issue given that the motor sits there. So unfortunately, I mean, there's a lot of other adjustment that's going to have to be done underneath. The belts coming off the motor have to go underneath. So don't really want to turn this on its side. What we're going to have to do is come up with a way of actually just elevating this whole assembly by a good, ideally about a foot. And we'll have to see what we can do about that. Alright, so I was looking for a stable solution to give me about a foot of elevation, and didn't like the idea of inverted plastic cups. That was about the only thing I could come up with off the top of my head. And as it happens, the wife just came home with several new 12 packs of soda, and that with a couple of slats of wood give me a nice stable platform that I can now come and get to most of the connections I need to get to underneath. This is going to be a little challenging because those are actually very close to the edge. Again, I'm not sure why these aren't on top, but since they are where they are, that's what I'm going to have to work with. And I might just have to slide this off closer to the edge. Okay, so setting the bed up here, centered above the holes, gives you an idea of possibly why they chose to put those connections on the bottom, and it's simply because the length of those parts would have limited the depth, so the bearing's just a little too long for that to fit. They made this center section just tall enough to clear the motor, which is nice, so that actually sits all the way to the bottom. That's basically the bottom out point. I don't know if that corresponds also to part of the leveling concept or what. We will have to see how that works in terms of a vertical limit. So that should be interesting. Oh great, more packing tape. Pulled the chrome rods out of bubble wrap, and look what we have. All sorts of tape, which means all sorts of glue stuck to the rods, and that's going to be real fun on the threaded rods, I'm sure. So, see you after about 30 minutes of cleaning, I'm sure. Well, as feared, there's plenty of tape residue on these chrome rods. They are oily, but that wasn't enough to prevent the tape from sticking. So we'll see how long it takes to come off. Hopefully the smooth chrome will let this come loose easier than the aluminum did. Alright, so after not quite as much cleaning as on some of the other stuff, but got all the rods cleaned and went ahead and went down the threaded rods too, which is a bit more time consuming, and have them inserted in place. Currently the rods, as you can see, I've got this one that's already fallen back out. Part of my problem is that these require much more clamping force than anything else so far. So in order to squeeze that aluminum, I really am going to have to get a normal right angle Allen wrench. And since I don't have a metric set here, at least I don't think I do, this will have to wait, but it's already late and I've wasted most of the day fooling around with this thing one way or the other. So I'm going to call it quits and come back to it next time it rains, which is scheduled to be Saturday. So talk to y'all then. All right, so we've completed the bed installation, and I managed to get some of my other tools to be able to finish up the clamping of the vertical rods, since that actually requires quite a bit more torque to torque those down. And we'll go through the process a little bit because, again, the guidance here isn't very realistic. First off, ignore this picture in terms of thinking that's where you need the bed to be as you start installing this stuff. I think this is just to give you a view of what the bottom connections are, but there's no way you're going to levitate that bed like that. So just set the bed down just like you see it here, and slip the rods in. You're lining everything up, and as you recall, I said to leave everything floating on the top and the bottom. And if we go to the next step, what you see is a whole list of well, now go adjust things and make sure you loosen things up if you need to in order to make adjustments, etc. So if you left those loose, like I suggested, then it actually is just part of the process of installing this stuff, is that then you tighten it up and you get it done right, as opposed to coming back and loosening it to get it correct. Now, the rods themselves are relatively straightforward. They should be essentially flush top and bottom, or very close to it. So, if you look down in the hole here, you'll see that that rod is essentially flush on top. And if I were to dig down underneath, you'd see close to the same thing. Now, once you slip those rods in, the center rod, the actual threaded rod, is really amazingly loose in terms of how easily it goes into this. It will just, gravity will make it fall down. And the challenge is actually to get it through the bearing. Now, this side, once I pulled the set screws out, went into the bearing fine and would continue falling down if I didn't hold it in place. The other side, I actually could not get it on at all. Now, when you're installing those bearings, there's actually some direction about the fact that they're supposed to float. They're actually supposed to be able to tilt back and forth. And this particular one was slightly crooked, and even after trying to straighten it out, I still couldn't get the rod to go in. So I actually pulled the screws to let the bearing float, slipped the rod in, and then when I tightened it down, I straightened the bearing out in that process. Now, tightening the rods, these linear bearings are pretty much holding those rods in place. So when I went and finally clamped the screws and nuts down, that was straightforward. However, since this has this whole floating bearing, and you'll notice is not held at the top, that's to allow it as much flexibility as it needs. What I had to do was very carefully, as I was tightening the two sets of screws that are holding that bearing in place, I was actually pushing side to side, trying to keep that threaded rod as close to vertical as possible. Essentially just using the hole up there as the guide, and also sighting down, you can see it there with the camera, sighting down the line to try to make sure that everything was in line. Now, once I had that, I essentially had the bottom taken care of. The problem, of course, is that even before you do that, you needed to set those set screws. You need to actually, sorry, it's relatively difficult. Get the right part here. You see the set screws that are in the bearing that actually clamp onto the threaded rod. That's what holds the height of the threaded rod, and so that when you turn the threaded rod, that's what actually will now lift the table. The directions say, well, just clamp it in. But again, no indication of height. So at that point, I decided to jump quite a bit forward in the assembly and go ahead and work, since I already had this thing lifted up, go ahead and finish the Z drive. And there's a couple of reasons for doing that. One, of course, the first thing was to just get the pulleys on so that I could determine just how much threaded rod needed to hang down from the bottom. And so once I did that, you'll notice that one pulley goes on with the mount to the top and the pulley to the bottom. The other goes the other way. That's because you're driving it with this double height pulley on the motor. And then you've got the two tensioners. One comment on this design, and I didn't realize this at the time because I remember them talking about dual drive. Well, they've got a dual belt drive for the X-axis, but unlike my Robo, which is actually has a dual vertical drive and has two motors driving those two verticals on it, this really just has the one motor and all the belts. So while that does keep it synchronized, it's actually a little bit more play in the system, I would think, because of that. Now, these tensioners let you tension it pretty well, so hopefully that won't be an issue. But still, I would have liked to see dual drives, especially for something this massive in terms of the bed. Now, the other reason for completing this stage of putting this on and tensioning the belts and all of that, sorry, my autofocus went out again. The other reason for doing that is because the only way to levitate this bed was to have something hold it. If you could lift the bed and it will just fall right back down because it actually spins that easily. But with the motor on now, it's possible to actually come in here and just by pulling on one of the belts, I can raise this up. The reason I wanted to do that is I left the upper mounts floating, right? We had the bottom ones floating. We bolted those down with the bed in place so that the bed was actually defining where that clamps. Now, as we came up to the top, everything else is floating. And now with the bed up at the top, the bed is again driving the position of all of those to where they want to be. And then you clamp it down, and now you have everything perfectly aligned, perfectly straight. And the only potential issue would be that over that height, that there could be a slight left to right variation but that would be a fraction of the width of the screws in their slots. And I'm not overly concerned with that. And frankly, if I were to put a square on here, there would be absolutely very little chance of me actually seeing that. And so basically, like I say, I'm using the motor to provide just enough friction to keep this thing up in the air when I lift it up. The motor and actually, I guess, the tension between the belts against all the pulleys. But you'll notice as it comes back down, it comes back perfectly level along the seam. So, like I say, I skipped ahead. Basically, what I skipped was installing the extruder. Who cares about the extruder at this point? You're installing the bed, finish installing the bed. So, Z-axis is now complete, including the drive system, the belt. Since I got my tools here, I thought I would fill out a few more pieces of information. Basically, the M3s, the smallest nylock, require a 5.5 millimeter. Well, apparently Craftsman decided people only needed single millimeter spacing instead of paying attention to what the standards were for M1, 2, 3, 4, etc. And so they provide a 4 millimeter, a 5 millimeter, a 6 millimeter, 7, 8, and so on, but no 5.5. Luckily, a 7/32, don't know if that will focus. There you go. So 7/32 actually works quite well. So if you don't have metric, it turns out that for these sizes, 7 millimeter is the next size up. That's what I've got on the wrench right now. Well, 9/32 will do just fine for that as well. Frankly, for some of these, since there's a little bit of tolerance, the nuts are slightly smaller than the socket size to, make it loose. In some respects, the English sockets fit a little better. And then at the 8 millimeter for the M5s, a 5/16 works. So the good news is you definitely have to have metric Allen wrenches or, the hex like I was using. But you can get by with English socket set. And that will make life a little bit easier versus using the crescent wrench that I did for the majority of the first part of this. Now, on the Allen wrenches, we already talked about the fact of we needed a 3, a 2.5, and a 2. Well, the last couple of things just added the need for a 1.5. And that was for the set screws on the bearing here. And, surprisingly, different than all the others, but the set screws for this double-sided pulley actually required that as well. Now, the interesting thing on that pulley, those set screws that they supplied are also very short. So these are different than all the other set screws that are in the rest of the kit. Luckily, it had 2 of them in. Turned out when I started putting these, the 2 large end pulleys, They have 2 openings. They only have 1 set screw in them. I had to use out of the kit the other set screws. But like I say, the ones here, they're the 1.5 drive, and they're actually very short. So you have to be able to reach quite a ways in. You can see if you look down that socket that set screw is way down in there. So just a little bit of an oddity. All right, so I wanted to get a good view of the 2 tensioners here and see just how that belt looked once they're tight. The taller one it's still awfully close to that, so it probably would be better to have the longer screw on that one and get it, say 3 nuts or more away. I may still come back and look at that. I'll have to prop everything back up to do it. Other than that, the one comment I wanted to make was the process of tensioning itself. The way I left it loose actually worked pretty nicely because as you pull that belt tight, there's enough torque on the screw trying to tilt over that it basically binds in place. And you could probably almost never even tighten that, but over time you'd worry that it could work its way and slip loose. So, but in terms of the actual adjustment process, it made life really easy because you could pull it out, get it completely tensioned, and then come back and just tighten the screw. And just for comparison, this gives you an idea of where those two tensioners actually got set by looking at it from the top. You can also see, it did a decent number on the paint job just in the process of having it sitting in there and scraping it up for a little while. So one last thing regarding these clamps. If you'll recall, I chose to put the two socket head cap screws facing outward. Turns out that since I had to use a right angle Allen wrench to get those torqued down anyway, that really wasn't necessary just because of the spacing. Before I was worried about getting the screwdriver in there, but there was plenty of room. Would I do it this way again? If I had a table and was working both sides, then yes, because that makes life easier to face them. You work on each one from the closest end. In this case, it would have been slightly easier if they had both faced forward. So if you're working on it from one side, you probably want to face them both forward. If you're working on it all the way around, then having it face the way I ended up is probably the best bet. All right, so let's back up here a little bit and give you the full picture with my lovely soda cartons that my wife's going to want back from me at some point here. So that has us ready now to go ahead and start putting the extruder on the top, find out how that belt ends up working out, and we will go from there. All right, I thought I'd pause here because at this point the instructions diverge. So after the initial part where I skipped forward, talking about how to put the bed on, you go to the extruders and it says for dual extruder skip to the next section, which of course is what I'm doing. You'll notice there's one part here which basically is the motor mount for a single stepper motor, versus as I come over to the dual extruder, it uses all of the same parts. So this part and these two parts, this one and these two are the same. This is an additional part. Now all of these were in the kit together. This was separate with the larger parts. So I don't know if it's just because it was slightly larger or if this was tossed in separate specifically because I have the dual extruder unit. So first off, if you're doing single extruder, from here on you're pretty much on your own, although it's not going to be much different. For the dual extruder version, you've got this extra part for the motor. I don't know if you've ordered single extruder whether or not you'll see this. Hopefully they provide it so that if you later decide to upgrade, you've got that part, but hard to say. So I'll start putting these things together and come back to you in a minute. Alright, if you watched my unboxing video, you've actually already seen some of these parts. Here is the dual feed single extruder, not dual extruder. So it's a dual drive Bowden, but it's just a single extruder. And then this is the proximity sensor for your height calibration. And that's basically the only thing shown on this page is basically mount that there on this part and mount this using the upper set of threaded holes to that. And so that's the extent of the direction. And then lo and behold, from page 37, we go to 38, which is finish the drive that I already finished. So to help resolve that and figure out what to do with all the other parts, we're going to have to go back to the thing that it said to skip, because this has, okay, here's the only a single mount approach, but basically this gives you all of the other things, including some wiring information and things like that. So we're going to need that information, at least to some extent, and I'll try to fill in the gaps because it is going to be slightly different. First off, you got two motors, but we will take it a step at a time and see where we end up. Well, we're back again, and given the obviously incomplete nature of the information here, I shouldn't be surprised to find that it's all wrong as well. So this calls out using M3 16 millimeters to attach the hot end, and then came with sensor for the nut and screw to hold the sensor. Well, guess what? This is the way the sensor came. It was just plopped in here open. There are no extra screws. There's nothing but the Bowden attachments in there. So I'll have to find something that fits there. But the other thing, as we've seen before, the 16 millimeter is far too long. It bottoms out in the hole. That's a 10 millimeter, and this time there's a decent amount of thread that catches. So with the 10 millimeter loose, it's probably hanging out just a little less, maybe half the distance that this thing's out when I first put the 10 millimeter in. And actually, let's see if we can back that out real quick, and I'll show you the difference before I put the other one in. So there's the 10 millimeter just sitting in without screwing it in. So it will have a decent amount of engagement into the hot end. Now the other question on this, which I guess is probably going to be fine, you'll notice that basically we're screwing this thing in to a piece of aluminum sandwiched with a piece of plastic. Now, granted, a lot of hot ends end up being held on plastic parts, and there's a fan that's plastic already on here. So we're on the part that's going to be being kept cold, right? The hot end is actually down here. Still is a little bit of a concern as to what that would have, what effect that would have. But I think in this case we're just fine, given that it's on the cool side of the hot end. So we'll see how that turns out. Looks like from the hole size that needs to be M3 for the sensor too. Presumably I'll be able to use the 16 millimeters that didn't fit here. I just hope I don't run out of 10 millimeters. Well, and we're back again. So the M3 by 16 is not long enough. Basically, this thing is, I believe, 4 millimeters thick. So to get through that, basically I need a 20 would leave me that much thread hanging out the end, so I really need to go to a 25. The kit does have some 40s, but those are way too long. Actually, are they 40s or 30s? M3 by 30. And I don't exactly know where that's supposed to be going. So the only other thing I can find is there are, it uses some M3, the really long ones, sorry. So it uses these very long M3s to actually hold this whole assembly together on top. But there's some standoffs for the circuit board, which I'll go ahead and show you this. So this goes up on top. So you can see that you've got your connections for the fan, the level, and the thermistor, as well as the 2 green leads for the heater. So the good news is they aren't trying to draw the current of the heater through this RJ45 Ethernet type connector. I was looking closely at the thickness of the traces on the circuit board to see how they would handle the current. They do definitely have bigger traces for the heater, but you know, every one of these connections adds some loss, so you know, you're heating up points on this board as well. The other board that was in this same kit is also just a signal routing board. This is obviously going to go down on the bottom somewhere, and this is where you've got the feeds to the 2 different RJ connectors, as well as some other things locally. So we'll use that somewhere later. But these were all in the Bowden kit. Actually, these may be, a couple of these are probably driving the Bowden, which, by the way, looking back at this plate, you know, obviously you'll mount the 2 motors on there, but this, unlike the other assembly that was direct drive, these motors are going to just mount up on the rail system. And I think I'll look at the picture that they have online to see if I can see where they put it. But what you have is you have the Bowden assembly, and hopefully those are all the screws necessary to attach to the motor, although since I believe you've got to go through the motor to attach that, so I believe this is going to be like this, and then this on top. I don't see long enough screws to handle that either. So we may be spending quite a bit of time buying hardware tomorrow. But I think this is where we are stopped, because without the right size screws, I can't step forward much further. So we'll pick this up when I get some more hardware. So I decided to take a few more steps, since I'll be able to come back and put the sensor on later, since it's going to need to be adjusted in height anyway. So the first step doesn't actually show this in any sort of steps, but the first thing is to actually attach this H-shaped piece to the carrier, and then what you have is you have the other H-shaped piece will become the bottom piece. This again is this tabbed approach, and so there's your hot end, and on the other side is basically just a blank plate, and then that circuit board will be on there with some standoffs. So this is going to be a little tricky, obviously not something I can do holding a camera. So. Alright, so here we have the hot end sans height sensor assembled essentially the same as this shows, except without the drive stepper motor. So you can see the little jumper board. So these will be going down through a cable harness, and all of this will be connected here and to that sensor. I have to say, putting this together, I mean, once you put these long screws in the top, at least you're not concerned about dropping it necessarily. But now that it's tight, it's actually pretty good. But the process of putting this together, this was the least impressed I've been about this whole slot and tab approach. The fit and finish really especially as it was going together, didn't feel right. And you're also, since you're using this to hold the circuit board and everything, you have to be concerned a little bit about how much tension you're putting on, but you need a good tension to hold this together tight. So, yeah, I kind of feel that this could be something a little more robust, a little better than what it is. Of course, it's not in the instructions anywhere, at least not that I've seen, but obviously you've got loops here to be running your belt around to the motor, and as expected, the only tensioning mechanism is going to be to slide this motor that way. We already talked earlier that without moving this rail off center from where they said to put it, there is no room to move that motor any further away to tension a belt. So it's going to be more work loosening all these up and sliding the rail forward some. I don't know. Kind of want to drop this down and see where we end up with the hot end relative to the bed. Actually, I guess it's the other way around. I got to raise the bed up. So let's do that. We know that our heated print area is just inside the head of the screws. Now, as the other thing, these screws actually are above the surface of the bed just slightly, which I'm not happy about. That implies that the head could actually whack it, which would not be good. A little further. Yeah, so see, we're already well past the edge of the bed. So right about there, sorry, I'll bumped the screen and lost the autofocus. Right about there is one end of the travel, and right about there is going to be the other. You notice, however, that 0 is way back here. So it's like, okay, it's designed to cover the whole bed width, but you can't print on the whole bed width. So now I'm very curious if I measure this bed, what part of the bed actually meets the spec in terms of the print area. So I will check that and get back with you. All right, so continuing on, Lowe's did not have any very short M3s, so I ended up with 440s. 1 inch long 440s are basically the same size as M3 25s. So that's what we've got on there now, and that should work. My only concern is I'm hoping that the metal of the screws don't affect the sensor at all. That's unknown at this point. As you can see, I have my belt installed, and I have to say, adding to this part in general, which I was not thrilled with, especially the assembly process, the whole belt structure, and I've already talked about the problems with this endpoint. This was a nightmare to get installed. My recommendation, if I were to have done it over, the big problem is there's no way to easily or otherwise get the belt into that slot. So, you know, what I did on the first side was I actually fished the belt in from the outside. Basically, you know, you notice you got the slot in the PCB for the belt access there. So I fed the entire belt through and around the motor, and came back and Managed to, after a lot of trying, catch the belt with my tweezers through the slot and pull it through. Of course, on top of that, I forgot the critical thing, which is that the belt has to go behind the circuit board, so I ended up pulling the bottom 2 screws to take the spacers here out, and then slip the belt back in, and then finally tension it. Now, a couple of warnings here. First off, you can only use a very small amount of material on this side. So you have to get that very close, because when this comes over and hits the limit switch, if you put much excess there, it will be in the gear or in the pulley. So you've got to be very careful about that side of it, that's got to be incredibly tight and short. The other problem, of course, is tensioning this, and as I said, without moving this rail, which would then throw everything else off in terms of the range of motion, there's no more meat to push that back because this PCB is here. Now, if I look very closely at the tiny little pictures on their website, this PCB does not appear to be the same as what they're showing on the website. That one looks like the limit switch is actually over on this side. So there's something different already. What I did to solve this, to give me some room to tension, is I actually went ahead and loosened both of the mounting screws, which of course ended up meaning this whole thing wanted to just fall off, so you have to be very careful with it. I set the belt position with this thing against the stop that it's supposed to be against, which is the machined part. So basically the PCB was just riding above the plate here. So, you know, we had that much give to work with. Now, then what I did, of course, was after I got the belt tie wrapped here, but before I cut it, making sure that I didn't run into any problems, then I pushed this back and until the PCB cleared this, put the screws in, and was able to tension the belt without running out of the rail on the back. So, you know, I'm basically back where I was with that in. So, in all, I would say that this assembly portion could use some work. And of course, from here on, we're really running blind. I mean, there's not really any information about the color code on this. I may try finding the manufacturer just so that I know which of those is supposed to be positive and negative in order to hook it up. There's a question of, well, for something like this, I want to run it across the top, but there's really nothing here in terms of cable management. Most of this, in terms of the wires, it's going to have to come underneath. And of course, it all goes into here. So, you know, I'm not ready to cut any of those connections yet. But this is all going to be the wiring there. Notice the fan, of course, is a standard fan. It's got a plug on it, but the fan connection is just a wired connection like everything else. So you have to cut that off at whatever length and just wire it in. Now, before finishing that top assembly up, it was getting too hard to work with at the height it was at, so since I'd already finished the base, I went ahead and pulled the supports out from underneath. So I already pulled the supports out from underneath, so all I expect to need to route underneath later will be some of the wiring that will go out of this corner box and go underneath. The next step I'm working on is I've actually started assembling the Bowden feeds. Again, there's a tiny little picture that shows this, so it's at least given me some idea of the orientation, that basically they made these symmetrical, so the two feed from the center, best I can tell, the connectors are on the outside, and that makes a lot of sense. A couple of points here, just in terms of how far I've gotten so far. You can see I've gone ahead and mounted one up. I'm using the 16 millimeter M3s. There are some M3s that are in the little kit here, but I don't think that they certainly aren't long enough or wouldn't have much grip through this. So I suspect if I went online and started searching, this is probably a stock part from somewhere. And so you could probably find directions on exactly how to use it. In terms of the motor, you'll notice I put this on first. Of course, I'd already assembled this before I realized that, wait a minute, I'm not going to be able to get both of these set screws on. The other thing, you'll notice I put the set screw at the bottom and have this thing flush to the top. The reason for that, and we'll try to show you here, if you look at the level of the hole that the filament's going to run through from side to side, if I put that set screw on top, the filament runs right through the set screw. Here it just barely misses, but by putting that towards the bottom, and potentially you could cheat the whole cylinder down a little bit, but I figure I'll have better luck with a completely uniform set of teeth rather than hitting that set screw once every revolution. That to me is not a good idea. So from here, there's a few more parts that come off of this. So this part goes in the middle. That will actually have the bearing and springs that tension it, and then you've got just a cap that goes over it. So give me a little bit more time. I'll finish putting these together and see how they perform. So I've gone a little further on the Bowden assembly. Got both of them mounted to the motors with the drive on it and the connectors in. And on the one side, I wanted to, before I close this up, I wanted to show you how the spring assembly and pulley portion go in here. So basically, the filament will come in from this side. It'll come out from the bottom, and obviously one motor will have to run clockwise, the other will have to go counterclockwise to drive this, because they're being put face to face. So presumably that will be a software or firmware configuration somewhere. Now, this is the biggest challenge, is getting these springs in, and let me show you a little bit about some of this. So the pulley is pretty straightforward. There's a big screw in here, and you just you can see the bottom of this piece is threaded, and you just screw the screw through. You don't want to tighten it too tight. It'd be nice if there was some thread locker on here. And I don't have any handy, otherwise I'd probably put some on it. But you need that actually loose. Otherwise, this aluminum part, you just squeeze it down and you'll actually crimp the pulley. Now, on the back side, you see these two threaded holes. Those are coupled with these two slots. So the two little springs that you see in here, the springs will actually go into those slots, but to hold them on this side, when you screw these little M3 10 millimeters in, so you screw two of those in all the way, and you have just basically a little stub out. So the stub goes in the center of the spring, and then the base of the spring goes on the other side. Now, putting that together, essentially what I had to do is you come in here and you put it like this, and using my tweezers again, put the springs in, and with a lot of fiddling, because the instant you get one in place, the other one falls out. But eventually, if you can get both of them hooked on the screws in the front and in the holes in the back, then you just push the whole thing over and snap it down in, and you're set. If I were to lift that up, this whole thing would go flying apart because there's quite a bit of force on that. So it's not a delicate operation at all. You're going to have to put some force behind it to get that. But I mean, that means it's really crimping hard. The other thing to remember, because of course I did it backwards the first time, head of the screw has to be on top. It doesn't fit in that little slot down there. So if you look at the cover that we're going to put on now, the cover actually is slotted for that screw. So it will not go together upside down. So just one more thing to remember. And then 2 10mm M3s in those holes, and that one will be done. I'm not exactly sure what the other holes on the sides of this were. I don't see anything in the documentation. I think they're just different mounting mechanisms, and possibly a lock for holding things back, but it doesn't appear in the pictures on the website that anything is used. So I'll come back and finish this shortly. The one thing I did want to mention, since, I got on the website trying to look at those tiny little pictures to get some guidance on this, and previously I was talking about the dimensions of the hotbed and the print bed in general. I'm disappointed to say now that the spec that they actually have, which is I believe 740 millimeters by 350. Well, handy dandy metric tape measure here. 350 is to the edge of the bed. Sorry, get my finger out of the way. So that's a complete lie. I'm sorry. I ran through the same thing with the Robo 3D, where, okay, if you get everything adjusted, you might be able to get the dimensions they did, but the problem was the hotbed was smaller than the specified dimensions. Here, not only is the hotbed smaller, but because they did such a poor job of machining this plate and the screws won't completely countersink, it'd be one thing if there was a hole there that you went over and, okay, you got filament down in it, but you could potentially use it. Here, you're going to hit your head against the tops of those screws. So I don't plan to print to the end of this unless I do something to fix that. So the reality is, at least as far as the bed is concerned, and looking at where the heater is, this is really a 700 by 310 millimeter usable surface area. And that's really to the very edge of the rubber on the heater underneath. It's probably, the aluminum will help carry the heat some, but the actual heating element's going to end inside that rubber boundary. So I would not count on it going much further than that. So not unusual that manufacturers play specsmanship games, but the reality is you cannot use this to the dimensions that they said and get decent results. So I wanted to come back to this part before I assembled it and let you see the components. So here you can see those 2 screws pushed all the way in and how that creates those little studs. And the other thing on the center screw, we're up to a new tip. Not positive what the metric size of that would be. I ended up using a 5/32 tip that fit it just perfectly. So whatever the metric equivalent of that is, I can double check, but that's what you'll need. And so, like I said, the installation process here is really place this like that and come in here. Again, handy dandy tweezers. These are not very compressible. They're very hard springs. So you're more just trying to physically place them in place. And so you can see how, okay, I get it in one side, but without a lot of care, I might not catch that screw. So I get one on the screw and push and hold it in, but then getting the other one on the screw, since I can't compress it, I have to actually pull it back a little bit, and the other one falls off. So it's a little bit of back and forth trying to get both of these in place. So I'm going to do that, pop it on, and close it up like that one. And then this will be done, and I can install it on the rig. So, got both of them assembled. Second time was quite a bit easier, getting those springs in place and getting everything snapped on. And of course, putting it on the right way the first time helped. Final step is actually two M5 T-nuts. And we're basically going to attach it to the center of the top rail, basically splitting the bed size distance, so that basically the hoses will only have to go half the distance. And after mounting on the center of the rail, there you have it. Again, this is a situation where for this long of a rail and that amount of weight, plus the weight of your couple of kilogram spools, this top rail, frankly, at least the back rail, should really be one of those 2x4 sized rails to make it a little more rigid. I mean, you know, it's solid, but it disturbs me a little. I think it could have been better. Then we have this somewhat hokey looking T that is going to mount right here as our spool holder. Couple of problems. First off, apparently this thing slipped on the machine or something, because you can see that the bottom of this T is not square. So it got machined badly to begin with. So the whole thing, I mean, it just looks horrendous. But I'm also looking at this nice serrated metal that we have on the edges and wondering how long the spool, you know, when's the spool going to bind up? How fast is it going to eat the plastic away inside the spool? How much is that going to drop on our printing bed? I suspect I'll be replacing this pretty quickly. This really, I don't like it at all. Yeah, so if you couldn't tell that it was crooked before at the base, now that it's mounted, you know, I mean, let's see, from there to there, you know, I guess it would be better to actually do it this way. So let's see, just under 12 and 12 and a half, so decent amount of delta there. Gonna hang a couple of spools on it just to get an idea what it looks like and how easily they slide around on it. We'll come back and see that in a second. So I just grabbed a couple of empty spools that I had handy, and so there's no load obviously because the spool's empty, but just to give an idea of how they're rolling, you can see, yeah, it's gonna be nice and squeaky, and you know, it tends to ride up on it, so yeah, we'll see. Now, here's the bigger problem though. So, another spool. Well, so that spool barely fits there, but once it's on, I can't get it the rest of the way. So this spool wouldn't work. And then we've got this spool. And so forget that. So as long as you're using standard large spools and not the short ones like People like Robo 3D like to provide. You may be okay, but it's not going to fit everything. So again, that holder, that was a really major afterthought. That was not well designed. So looks like I'll be printing my own. All right, so with that, the major mechanical assembly is essentially complete. The only components left are the housing for the power supply and control boards that all go down here in the corner. So this part here will be on the outside. You see the cutouts on the corners to match the corners there, and has their little FT-6 logo and fan. This presumably is the inside side, and then the top, and then we have for the little display board, and over there still in all my pile of mess now is the one for the display board I have. This one may also be optional. I'm not sure. We'll see where that fits. Again, no instructions, so it could actually be an internal component. So with this, I'll probably piece this video together and post it. The next step, obviously, is all of the electronics and cabling. Not necessarily worried about doing that, except for the fact that I'd really appreciate the guidance on cable links. Since most of this stuff has not been pre-cut, knowing the appropriate routing and links to use is a pretty critical step. And so your choices are either, okay, leave everything long and have stuff flopping around that you then have to deal with again later, but the risk of cutting something short is not good. So we'll see. I may work on it tomorrow, or I may wait until they get back in the office, which probably won't be till after the new year. They still haven't responded to any emails or online discussion to date. So, but we'll get this posted, and hopefully this helps out anyone else who's looking at this printer.